I think one of the biggest challenges that I face is that when we are doing modifications on these plants, we are using two different systems for doing design in 3D. The problem with those software is that it's not very easily accessible and quite expensive.
Brownfield projects, those performed on existing plants, are the vast majority of projects now planned or executed worldwide. A brownfield project's workflow differs from a greenfield or new project's workflow in that the project must accurately model tie-in points to existing pipes and equipment for new equipment and piping relative to existing components and removal of components no longer needed. To accurately depict these tie-in points, a 3D model of the existing plant should be created. But this can be an expensive and time-consuming process, especially if an existing 3D model has not been kept up to date. Autodesk Plant Design Suite software helps to address the unique requirements and workflows for plant modifications and redesigns. Laser scanning, for example, provides a quick and reasonably inexpensive method for creating a 3D model in the form of point clouds. Each cloud point is a point on the physical model, thus giving a more accurate 3D representation. Using tools available in the suite, intelligent 3D models can be built more quickly. Project engineers can then more accurately design the new project equipment and piping, and check for clashes against existing structures. By taking advantage of tools that perform clash detection against point clouds, only select areas of the plant need to be converted into an intelligent 3D model, helping to save time and costs. To begin the project, we'll need to create a computer model of the part of the existing facility that applies to the project. We can then more accurately design the required changes. Let's start with a reality capture setup. On the right-hand side, we have an AutoCAD file containing captured point clouds. These point clouds were created by performing multiple laser scans of the project. On the left is the point cloud in native format, with color information associated with each point, giving it the look of a 3D photograph. By manipulating the scan data to focus on the area of attention, we can start to create a more accurate model in AutoCAD Plant 3D. We will select the piping component from the catalog, and then place it by selecting points on the original scan. We repeat this process for all components and pipes until the model is completed. We have completed the process of picking from the clouds, but the piping is still hidden. We will use piping intelligence to complete the modeling by assuming connections based on the specs. With the piping complete, we can create isometric drawings at any time, complete with bills of materials. Tie-in points are very important in revamp projects. Plant 3D with reality capture allows tie-in points to be created quickly and precisely. We use the existing pipeline to help determine the tie-in point as shown here. Once that is located, we can use that point for new piping. Finally, clash detection for revamp projects is very important, but can be extremely difficult since not all of the plant is modeled. Autodesk Navisworks Manage supports point clouds, so clash detection can be performed to check new piping as modeled in Plant 3D. With the existing plant represented by point clouds, there is no need to convert the clouds. Here, the Clash Detective has recognized some potential clashes. The first one is unimportant, since the piping is going to be removed. But the second clash is important and needs to be corrected. With this short example, we have shown you how Reality Capture and the Autodesk Plant Design Suite Ultimate Edition can help you quickly get to work on revamp projects.
Statoil Hydro is a large oil company. It has international operations, mainly located in Norway. It is where we have had our first plants, and we have about 30 or 40 oil plants offshore in the North Sea. And all our plants is constantly changing. They are modified all the time.